My name is Tony Coverdale and I am the chair of the Saltford Brass Mill project. The brass mill, which is a scheduled monument, was in operation from 1721, and it was while researching the 18th century brass industry that I kept finding references to John Padmore, and the realisation dawned that here was a character who was worthy of further research in his own right. A painting of John Padmore has survived, which is in the collection of the BRLSI. The painting is currently on loan to the Victoria Art Gallery and is on display in the assembly rooms. On the north wall of the octagon there are 3 portraits, and the portrait on the right is of John Padmore. The painting shows a man with a rather sallow complexion, but this is the man who has been variously described as the ingenious Mr. Padmore, and also a man well known for his genius in mechanics. His works span a period of nearly 40 years, from 1695 to 1734, and include pumping engines and waterworks, smelting works and mills, harbours and navigations, cranes and railways. The painting shows Padmore with a crane, clearly a machine of which he was proud and of great importance to him. To put Padmore's work into historical context, his pumping engines were constructed 70 years before James Watt made his important advances into the design of the steam engine. Padmore's work on the Avon Navigation was carried out 70 years before Rennie began work on the Kennet and Avon Canal. And Padmore's railway was constructed 100 years before Brunel started work on the Great Western Railway. We have Padmore's last will and testament, which was proved on the 11th of July 1735. Padmore declares himself as indisposed in body, but of disposing mind and memory, implying that he was seriously ill and aware that he was approaching the end of his life. This may also reflect the sallow complexion in his portrait. Padmore describes himself as a millwright of Barton Regis in Gloucestershire, married to Sarah, with whom he has 3 daughters. The first item he addresses are his 5 shares in the Brass, Battery and Wire Company of Bristol, Esher, Upper Redbrook and Barton Regis. This was the Bristol Brass Company, the company who owned Saltford Brass Mill. He left his shares in trust to Nehemiah Champion and one Cypherus Tyndall to provide for his wife and daughters. Champion was the head of the Bristol Brass Company, and one Cypherus Tyndall was a merchant venturer and banker who was to be a founding member of Bristol's first commercial bank. A search of Bristol's parish records reveals that in 1720 John Padmore married Sarah Holbrow in the church of St Augustine the Less, located just off College Green in the heart of Bristol. This is clearly our John Padmore. Looking further back in the records, we also find a John and Elizabeth Padmore in Bedminster in the 1690s. Given that we have evidence of Padmore being active between 1695 and 1734, was Sarah John's second wife and Elizabeth his first wife, or are we looking at 2 people, a father and son, John Padmore the elder and John Padmore the younger? Is the portrait in the assembly rooms a portrait of a man in his 70s, approaching the end of his life, or a man in his 30s, suffering from a terminal illness? It is my belief that we are looking at 2 generations of millwrights, a father and son, the elder and the younger. Turning then to the main subject of the talk, John Padmore's engineering achievements. In his portrait, Padmore is shown demonstrating a model of a crane, and achievements of which he was evidently proud. The importance of the crane is reflected in the many references to the machine in writings, paintings, drawings and images of the period. If we look at a detail of the Samuel and Nathaniel Books engraving of the southeast prospect of the city of Bath, in the bottom left-hand corner we can see Widcombe and Dolemeads, with 3 of Padmore's achievements: the crane for loading stone onto barges in the river, the railway delivering stone from Ralph Allen's quarries at Combe Down, and a brewery. Padmore's crane also features in John de Sagulier's 1744 work, A Course of Experimental Philosophy. De Sagulier describes a number of machines attributed to Padmore, including a rat-tail crane, like the one in Book's engraving, with its associated reduction gearing, a device for hauling large loads along the railway, a treadwheel and a railway carriage. A model of Padmore's crane and railway carriage can also be seen in the Museum of Bath Architecture. The Segulier's drawings highlight a number of characteristics of the crane. Its construction resembles a post mill, with the machinery being housed in a frame mounted on a single vertical post. This enabled the crane to traverse its load in an arc around the post. The crane incorporates a reduction gear, which, in the words of de Segulier, is moved by a very small trundle or lantern, whose rounds take the cogs of a very large wheel, and so as to have the power of 2 men sufficient to raise the heaviest goods. The blocks of stone loaded onto barges in this way weighed around 1 ton each. The mechanism also includes a ratchet to prevent runaway of the load, described thus. Whilst the weight is drawing up, the rack teeth of a wheel slip round below a catch or click that falls successively into them, and so hinders the crane from turning backwards, and detains the weight at any part of its ascent, if the worker should happen accidentally to quit his load of the winch, or choose to rest himself before the weight is drawn up. The Widcombe crane was not the only crane built by Padmore, his most impressive machine being the Great Crane built next to the mud dock on the Grove in Bristol. As late as 1820, G.A. Cook, the author of a travel dictionary, recorded, "On the western side of the mud dock is the Great Crane, erected on 14 pillars, encased with iron, by the ingenious Mr. Padmore, a curious piece of mechanism and worthy of observation." The crane was installed some 75 years before the construction of the floating harbour. The mud dock or jib, which was served by the Great Crane, is seen on the extreme right of this map of 1815. It was to the south of Queen's Square, at the heart of Bristol's 18th century harbour complex. In the 1742 edition of his Tour, Daniel Defoe refers to the crane as being the workmanship of the late ingenious Mr. Padmore. This image of 1733 shows the Great Crane with the truncated spire of St. Mary Radcliffe and the glass cone in the background. The operating mechanism was housed in an enclosed frame mounted on 14 pillars, as shown in this image by William Halfpenny, drawn in 1747. The operating mechanism was connected to 2 rotating jibs, which traversed the wharf and the vessel being unloaded. De Segulier describes the crane as having 2 speeds. Low-speed operation was similar to the Widcombe cranes, comprising a reduction gear and safety ratchet. De Segulier goes on to say, "As there are a great many bales of goods 5 or 6 times lighter than the heaviest goods, and it would be loss of time to employ the crane in the manner already described to raise them, there is a contrivance to loosen the lantern or trundle from the cogs, and then the wheel being also a walking wheel, the same men will get into it, in which case they have power sufficient to raise small goods 5 or 6 times faster than the heaviest, so the crane becomes of general use." The Transactions of the Royal Society for 1764 include a description of a new and safe crane with 4 different powers, invented by Mr. James Ferguson, a Fellow of the Society. The crane includes a safety mechanism, comprising a ratchet to prevent the uncontrollable fall of a load, the catch being described as constructed much in the same way as in the Great Crane at Bristol, invented by the late Mr. Padmore of that city. The second of Padmore's inventions that are visible in books engraving is Ralph Allen's railway for transporting stone from the quarries in Combe Down to the quay in Widcombe. The railway also features in de Segulier's experimental philosophy. The carriages are flanged iron wheels which run on timber rails laid along what is now Ralph Allen Drive. Each carriage has a friction brake which operated on the rear wheels. The railway features in Anthony Walker's 1752 engraving of Ralph Allen's house and park. 2 carriages can be seen descending the drive, each being controlled by a brakeman at the rear of the vehicle. Richard Jones, Ralph Allen's clerk of works, recorded that large blocks of stone were lowered, seldom less than 5 or 6 tons at a time, by a masterpiece of mechanism. The Segulier also describes a rail-mounted winch, which could be deployed by 4 men to haul very large blocks of stone. The mobile winch sat on rails and was secured to a large stave driven into the ground. 2 ratchets operated on a toothed wheel keyed to the winch drum. The men alternatively rotated the winch through 1/8 of a turn by hauling on the pivoted beam mounted overhead. The third of Padmore's constructions seen in Book's engraving is Widcombe Brewery. A contemporary description describes the maker of the mill as John Padmore. The description goes on to describe how the mill was so constructed to grind and screen malt and pump wort up from the cask into the copper at one time with 1 horse only. And now we turn to Padmore's involvement in waterways and harbours. We have observed Ralph Allen's stone yard at Widcombe, but the next challenge was how to move the stone from Widcombe to Bristol and thereby to markets around the world. There were 7 weirs between Bath and Bristol, which meant transshipping the stone 7 times before the cargo even reached Bristol. Ideas had been floated to make the Avon navigable between the 2 cities in the mid-17th century, but had not come to fruition. In 1712, Bath Corporation secured an Act of Parliament to make the river navigable, but it was not until 1724 that a group of entrepreneurs formed a committee to turn the vision into reality. Ralph Allen was a key promoter of the venture and also the committee's treasurer. John Padmore is described as playing an important part through his technical skills in the execution of the grand design. Between 1725 and 1727, Padmore was contracted to construct the locks and cuts on the Navigation, and works which are attributed to him include Locksbrook Cut, including the bridge and western lock, Salford Lock and Keynsham Lock. Padmore also carried out repairs to the Navigation after it was opened, works being recorded at Swinford and Newton Ford, and these works carried on until his death in 1734. Historic England citation for the Locksbrook Cut and Western Lock is Canal Lock with gates, early 18th century. The Avon Navigation was opened in 1727. Engineer, John Padmore. Promoters, Ralph Allen and John Wood the Elder. 2 pairs of original form heavy gates. Beams contained on the north side by an arc of stone curbing set in the rising embankment. The lock basin walls extend approximately 55 metres, and the lock remains mostly unaltered. Historic England citation for the Locksbrook Cut Bridge is Accommodation Bridge over Canal, dated 1728. Engineer, John Padmore. Single span bridge with slightly elliptical eccentric arch. Adjacent to the Dolphin Public House, now the Locksbrook Inn. I'm quoting from Brenda Buchanan's 1996 paper on the Avon Navigation. On the 1st of November, the committee ordered that Mr. Hoare should give instructions to Mr. Padmore for a draft of the gates to be erected at Keynsham, and asked for a review of the siting of the wharf at Keynsham, which they thought inconvenient. Looking beyond Bristol, there is also evidence of Padmore's work earlier in the century at Sea Mills, where the River Trim enters the Avon, seen here on Benjamin Don's map of 1769. A ruined harbour wall exists across the River Trim where it enters the River Avon. This was a floating harbour, the objective of which was to enable ships to remain afloat, whatever the state of the tide, to facilitate loading and unloading. And by positioning the dock at Sea Mills, ships would not have to navigate the most difficult part of the river. Historic England's listing describes the walls as being by John Padmore, and highlight that the structure was the first floating harbour on the Avon, in use from 1712, and only the 3rd in the country after Rotherhithe and Liverpool. The harbour opened nearly 90 years before Bristol's floating harbour, which did not open until 1809. The promoter of the scheme was Joshua Franklin, but he was unfortunately ahead of his time, as there was no adequate road to Bristol and the cargoes had to be delivered to the city by barge. This negated the scheme's benefit and resulted in its failure. Even so, the scheme did succeed technically, and the harbour continued in use as a whaling station until 1766. Turning now to Padmore's involvement with the copper and brass industry. Padmore held shares in the Bristol Brass Company and clearly had a close relationship with the head of the company, Nehemiah Champion. At the time of Padmore's death, the brass company was controlling copper smelting works at Cruise Hole and Conham, and the alloying of copper and zinc to make brass at Baptist Mills north of Bristol, which was also the company's headquarters. The company also operated a number of battery mills located in Conham, Woodborough, Weston and Salford, and also a second mill in Conham engaged in wire drawing. Padmore would have had knowledge of the processes conducted at these sites, which takes us to the next chapter of the story. Padmore is credited with building a copper smelting works at Llangyfellig, north of Swansea, in 1717, and a copper mill on the River Towy at Lower Forest in 1734. These sites employed the same techniques as employed by the Bristol Brass Company in the Avon Valley, which were at the cutting edge of technology at the time. The question is whether Padmore copied what he observed in the Avon Valley, or was he the engineer who had built many of the mills in the Avon Valley, and what we see in South Wales are developments of his earlier work. The Llangyfellig copper works employed reverberatory furnaces, like those which had been perfected in the Avon Valley, to enable the smelting of copper ore using coal. The Llangyfellig works smelted ore transported from Devon and Cornwall using coal mined locally in South Wales. Each of the tall chimneys served a furnace, similar to the furnace observed by the German traveller Schluter in the Avon Valley in 1738. Interestingly, the promoter of the scheme was Dr. John Lane, who was also a proprietor of the Avon Navigation. In 1734, we find Padmore once again in South Wales, this time engaged in the construction of a copper mill. The mill is a water-powered battery and rolling mill, and displays many similarities to Salford Mill, which was converted to a brass mill in 1721. This includes multiple sets of battery hammers for the manufacture of hollowware, an annealing furnace, and 2 sets of rolls for producing sheet metal. The last of Padmore's achievements involves the design and construction of water pumping engines. In his 1824 History of Bristol, John Evans lists a number of entries for the late 1690s which relate to works by Padmore. The entry for 1695 states that an Act of Parliament was passed to allow the Bristol Water Company to draw water from Engine Mill at Conham to supply the city of Bristol via a reservoir at Lawrence Hill. The reservoir was still in existence in 1881 when it was recorded as a fish pond by the Ordnance Survey. And in 1696, Hotwell House was erected, which incorporated a pump for raising hot spring water some 30 feet to supply the spa, the spring being located on the banks of the River Avon, but below the high tide level. Turning first to Hotwells, the spa is shown on this map of 1815 to the west of the city, below Clifton. Writing in 1740, the physician and political writer John Padmore described the waters at Hotwells in his book A New Analysis of the Bristol Waters. He described how the spring at Hotwells issued from the base of the cliff in the Avon Gorge, between the high and low watermarks, making the spring inaccessible for several hours a day. Padmore describes how Mr. Padmore, a man well known for his genius in mechanics, enclosed the spring in a cistern and fixed pumps to raise the water almost 30 feet in all its native heat, purity and perfection. We are not told what type of pumps Padmore used, nor the method of powering them. Turning next to the Bristol Water Company, writing in 1820, Cook describes a curious hydraulic machine invented and constructed by the late ingenious Mr. Padmore for throwing water into a reservoir for use of the city of Bristol. This engine features on Don's map of 1769, described as engine house for conveying water to the city. Latimer, writing in the Annals of Bristol, published in 1900, described the scene thus. The promoters purchased the lease of the extensive flour mills at Conham Weir. The water drawn from the Avon at this spot was conveyed to near Crew's Hole, where it was driven by an ingenious machine, possibly a primitive steam engine, to a reservoir at Lawrence Hill, and there flowed by gravitation into the city. The whole of the pipes were bored out of the trunks of elms. The engine house near Crew's Hole features on this map by John Carey of 1815. The hollowed elm logs are reminiscent of the pipes used by Sorrocold for his water distribution network in Derby, seen here after being unearthed in 1928. Examples of hollowed elm pipe logs can also be seen in the Museum of Bath at Work. "30 years after the engine was built for the Bristol Water Company, Padmore is again working in South Wales, this time erecting a steam pumping engine for draining a coal mine on the Gower. But what were Padmore's pumping engines? Contemporary observers variously describe Padmore's engines as pumps affixed to a spring, by means of which the stream at Hotwells is elevated almost 30 feet, a curious hydraulic machine at Crew's Hole, invented and constructed by the late ingenious Mr. Padmore for throwing water into a reservoir for use of the city of Bristol. And there were formerly 2 machines for the same purpose at Crew's Hole at Conham, but they were taken down in the year 1720. A report on the state of large towns, written in 1845, stated that the machine at Conham Mills was a large wheel engine. And Latimer, writing in 1900, raises the possibility that the ingenious machine at Crew's Hole was possibly a primitive steam engine. Key events in the evolution of the steam engine are advances made by Watt, Newcomen, Savary and the Marquis of Worcester. James Watt entered into a partnership with Matthew Boulton in 1775 to commercialise Watt's invention of an improved efficiency steam engine. Newcomen had patented his atmospheric engine in 1705, with the first construction of a practical engine taking place in 1712. Savary published details of his atmospheric engine in 1702, which he had patented and presented to the Royal Society, and the Marquis of Worcester published his ideas for a water commanding engine in 1665. The engine on the Gower, constructed by Padmore in 1729, was most probably a Newcomen engine. The engine at Conham Mills is described as a wheel engine. There was a weir at Conham, hence the wheel engine could have been a water wheel driven pump. Padmore's engine may have emulated pumps designed and built by Sorrocold in 1692 to deliver a domestic water supply to Derby, only 4 years before the Bristol scheme. Sorrocold also used hollowed elm logs to distribute the water. Sorrocold went on to install a development of his engine in London, installing the machine under arches of London Bridge, using the barrage effect of the bridge to create the head of water to drive the wheel. But what of the curious hydraulic machine at Crew's Hole? There is no evidence of a weir or barrage here in the late 1600s. That would be needed to create the driving head of water for a wheel engine, in addition to which there was a very high tidal range, making installation of a water wheel challenging. Latimer suggested that Padmore employed an early atmospheric engine. But Padmore was working nearly a decade before Newcomen secured a patent for his fire engine, and Savary painted his pumping engine in 1698, 2 years after Padmore installed his machine at Crew's Hole. Some authorities believe that Savary employed ideas which had first been published by the Marquis of Worcester in 1665, described as a water commanding engine. Could Padmore also have had access to those papers? And was Padmore employing ideas at a time when concepts that were to revolutionise water pumping were in their infancy? So where should we place Padmore in the history of technology? If we accept that we are looking at a father and son, John Padmore the elder and John Padmore the younger, jointly their achievements include cranes, railways, navigations, locks and harbours, copper smelting works, battery mills and rolling mills, pumping engines and water distribution systems. They are working almost a century before recognised greats in these fields, such as René and Brunel. They are also contemporary with other greats, such as Newcomen, Savory and Soracold. And with respect to atmospheric engines, there is even a possibility that they were an advance of Newcomen and Savory. John Padmore, genius in mechanics, should certainly be remembered as an important player in the Age of Enlightenment, who laid the foundations for the Industrial Revolution. As for his painting, it is hoped that when the management of the assembly rooms reverts to the National Trust, that Padmore's painting will be returned to the BRLSI, where it can be part of a testimony to his contribution to the advancement of science and engineering.